Chalo. Now keep the heading. New topic we are doing. Moving coil galvanometer. Moving coil galvanometer. Galvanometer, you know, right? What is the purpose of galvanometer? What is the purpose? Anybody?
It detects change in direction of current.
स्मॉल करंट्स को डिटेक्ट करेगा, राइट. मूविंग कॉइल गैलोमीटर देखेंगे इसका प्रिंसिपल क्या है, वर्किंग क्या है. सो देखो, इज अ मूविंग कॉइल गैलोमीटर. आपको सिंपली क्या करेगा, व्हेन यू ऑन द व्हेन यू पास ए करंट, it will get deflected and it will show the reading of the current. When you remove the current, what will happen? It will come back again the same position. Now here आपको क्या क्या नेम्स आपको मालूम पड़ने का. दिस इज टू पोल्स, लाइक मैग्नेट्स है ना, परमानेंट मैग्नेट्स है. देयर इज ए मैग्नेटिक फील्ड, राइट. एंड देयर इज ए वन सॉफ्ट आयरन, आयरन कोर है. उसके ऊपर रेक्टेंगुलर वायर्स आर देयर, रेक्टेंगुलर वायर्स आर देयर. ओके. नाउ हियर क्वेश्चन इज, when you pass a suppose 2 ampere current, okay, exactly 2 ampere tak, why it is stopping? First question, why it is stopping till 2 ampere tak? Why it is not going away and again come back? Next step, next one, second question is, when you remove the current, again how it is coming back to zero position? Tell me. Normally galvanometer ammeter dekha hoga na lab mein, when you on the switch, it will show deflection. Exactly, it will show there only, it will stop exactly. If you remove, it will again come back to zero position. Why? Anything? Any idea? No? Okay. Generally, क्या होगा? Because of springs and wires. Spring ko, if I rotate like this, if I leave, what will happen? Again, it will come back to original position. Even pen also, right? Pen nib also. If you press, it will come back again. Okay. So क्या होगा? When you on the switch, the current is passing in the wire. Whenever the current carrying wire is placed in a magnetic field, there is a torque. Okay. When it is rotating, the spring also start rotating, right? ऐसा होता जाएगा. It will apply a restoring torque. Restoring torque. So ये बढ़ता जाएगा, ये भी बढ़ता जाएगा. एक जगह में exactly 2 amperes में it will restoring torque of the coil is equal to torque of the restoring spring का torque का दोनों match हो जाएगा. Then only it exactly stops there. And if you remove the current, there is no force on the this coil, right? That only because of spring, again it will come back to zero position. Okay. So majorly कहानी क्या है? Spring का कहानी है, springs and wires का कहानी है पूरा. If there is no spring, क्या होगा? It will go somewhere, it will stop there only. Again, if you remove also, it will stop. No one is there to push back. Okay, spring का वजह से आ रहा है. तो इसका प्रिंसिपल वर्किंग वगैरह देखेंगे. चलो, मूविंग कॉइल गैलोमीटर प्रिंसिपल लिखो. Torque on a current carrying coil when placed in magnetic field. So whenever you place a current carrying coil in a magnetic field, there is a torque acting on this. Because of torque only, the coil start moving. And torque formula, you know, M cross P or MB sin theta. Copy it when placed in a magnetic field. Okay. Now इसका torque का formula लिखेंगे. Working देखो. When current I passes through the coil, a torque tau acts on it due to magnetic field B, and the torque is NIAB sin theta. The torque का formula क्या है? Torque is M cross B. And magnetic moment, you know, right? Magnetic moment is IA. Okay. Or you can write first MB sin theta, right? M cross B का formula क्या है? MB sin theta. And magnetic moment is nothing but IA. IA. This is for one coil. If there are n turns आएगा ना? NIA. B sin theta. So like this we got NIAB sin theta. Torque. So theta is the angle between, very important, theta is the angle between magnetic moment and magnetic field. मैग्नेटिक मोमेंट एंड मैग्नेटिक फील्ड. एंड मैग्नेटिक मोमेंट का डायरेक्शन मालूम है ना, कर्ल द फिंगर्स इन द डायरेक्शन ऑफ करंट एंड थंब इंडिकेट डायरेक्शन ऑफ मैग्नेटिक मोमेंट. Wherever current passing, उसी डायरेक्शन में कर्ल द फिंगर्स एंड थंब इंडिकेट्स द डायरेक्शन ऑफ मैग्नेटिक मोमेंट. Okay. Now here our intention is to make theta 90 degrees. 90 डिग्री बनाने का. 90 theta is angle between what? Magnetic moment and magnetic field. देखो उसके लिए we are using a concept of radial field. Sometimes they will ask what is radial field बोल के. Radial field क्या है बोले तो how we are getting radial field means देखो because of concave poles. एक concave shape में poles है. एंड दूसरा दिस सॉफ्ट आयरन कोर इज मेड अप ऑफ फेर्रोमैग्नेटिक सब्सटेंस. आपको मैग्नेटिज्म मैटर में आएगा फेर्रोमैग्नेटिक सब्सटेंस. ये दोनों को वजह से वी आर गेटिंग ए रेडियल फील्ड. देखो रेडियल मींस परपेंडिकुलर. देखो इफ यू सी केयरफुली, सी हियर मैग्नेटिक फील्ड इज लाइक दिस. मैग्नेटिक फील्ड इज फ्रॉम ऐसे जा रहा है, नॉर्थ टू साउथ जा रहा है मैग्नेटिक फील्ड. एंड इफ यू सी एरिया वेक्टर देखो इस पे करंट जा रहा है ना, इसमें टॉप में करंट इज फ्लोइंग. दिस इज रेक्टेंगुलर कॉइल. See, actually, if you see in the side view, ऐसा रहेगा रेक्टेंगुलर कॉइल. देखिए ये ड्रम है, ये सिलेंडर है. ओके सिलेंडर ना, सिलेंडर के ऊपर में ऐसा रेक्टेंगुलर बांधा है, ऐसा रेक्टेंगुलर बांधा है. ओके दिस इज अ कॉइल उसके ऊपर. ओके नाउ इफ यू सी केयरफुली, कर्ल द फिंगर्स इन द डायरेक्शन ऑफ करंट एंड थंब इंडिकेट डायरेक्शन ऑफ मैग्नेटिक मोमेंट. So what is the angle between magnetic moment and magnetic field? What is the angle between magnetic moment and magnetic field? 90. Okay, so if you see anywhere, if you see this one, when the cylinder rotates like this, okay, that time magnetic field will be like this, and again magnetic moment will be changing, right? See, when the soft iron core is rotating, the area vector is changing. Area vector, the magnetic moment is changing, and magnetic field तो ऐसा रहेगा, right? ऐसा रहेगा. Based on this, if देखो इसका magnetic field is ऐसा, इसका magnetic field is ऐसा. So every point of time में magnetic moment and magnetic field is perpendicular. Because of this, that's why we are making a special design such a way that every point of time में the magnetic field and magnetic moment are perpendicular. Therefore, theta is 90 degrees. That is called radial field बोलते हैं. Okay, देखो.
Sir, I have a doubt.
Tell me.
So where is the current flowing again? I wasn't.
See, ये टॉप व्यू में दिखा रहा है, ये वाला टॉप व्यू में दिखा रहा है.
Right.
हाँ, see here cylinder is there, right? ऐसा 1 minute. हाँ देखो सिलेंडर इज देयर ऐसा. ओके नाउ कॉइल कैसे वाइंड किया, वी वांटेड लाइक दिस रेक्टेंगुलर ऐसा. इफ यू सी इन टॉप व्यू में यू विल सी लाइक दिस कंडक्टर. ओके नाउ करंट इज पासिंग लाइक दिस, राइट? ऐसे पास कर रहा है. सो इफ यू सी इन टॉप व्यू में द करंट इज फ्लोइंग लाइक दिस. ओके टॉप व्यू में. सो इफ यू फोल्ड द पेपर को फोल्ड करो एंड रेक्टेंगुलर कॉइल एक वायर से बंधा है, रेक्टेंगुलर कॉइल से ऐसा बाउंडेड. ओके इफ यू सी इन द टॉप व्यू में इट विल लुक लाइक दिस सिलेंडर में. ओके नो मैग्नेटिक मूवमेंट का कैसा आएगा? कर्ल द फिंगर्स इन डायरेक्शन ऑफ करंट एंड थंब इंडिकेट डायरेक्शन ऑफ मैग्नेटिक मूवमेंट. देखो मैग्नेटिक मूवमेंट इज लाइक दिस. And if you see the this one, magnetic field is like this. So angle between them is 90 degrees. So every point of time में magnetic field and magnetic moment is 90 degrees. That's why sin 90 1 हो जाएगा. Torque, maximum torque will be NIAB आएगा. Okay, that is called radial field. देखो radial field. A radial magnetic field is one where the magnetic field lines of force are always perpendicular to the plane of coil, regardless of its rotation. Regardless of its rotation, it is always perpendicular. Plane से perpendicular रहेगा. Okay, therefore theta is 90 degrees. That time torque क्या होगा? Torque is NIAB sin 90. So torque is NIAB. This is the maximum torque acting on the coil. So when you pass a current, there is a torque. वो torque कितना है बोलते हो NIAB and always sin 90. Always any motion में 90 आएगा. So एक coil का torque है, right? एक coil का torque है. Because of coil only, the torque is there. नो स्प्रिंग के बारे में लर्न करेंगे. कुछ नहीं, एट इक्विलिब्रियम में दोनों को इक्वेट किया था, विल गेट ए फॉर्मूला. ओके चलो now देखो. Now radial field is generated by using, they will ask sometimes radial field कैसे आएगा, because of what means one is cylindrical concave pole magnets, एक concave के वजह से they are getting a radial field, and दूसरा soft iron which is made up of ferromagnetic substance. ये दोनों को वजह से we are getting a radial field. Okay. Now, once the coil starts rotating, when the pointer is start rotating, the wires and the springs get twisted. ट्विस्ट होता जाएगा. मतलब इट इज अप्लाइंग ए रीस्टोरिंग टॉर्क. बैक से आता जाएगा, टाइट होता जाएगा. सी रस्सी को इफ यू बड़ा रस्सी ले लो, इफ यू गो ऑन फोल्डिंग फोल्डिंग फोल्डिंग, एक सर्टेन टाइम में रुक जाएगा. इससे ज्यादा नहीं होगा. व्हेन रिलीव व्हाट विल हैपन, अगेन कम बैक टू द ओरिजिनल पोजीशन. ऐसे ही व्हेन द पॉइंटर इज रोटेटिंग, द स्प्रिंग इज गेटिंग रोटेटेड एंड फाइन वायर्स आल्सो गेटिंग रोटेटेड. मतलब दिस इज अप्लाइंग ऑलवेज रीस्टोरिंग टॉर्क. ये अप्लाई करते जाएगा, ये बिकॉज ऑफ टॉर्क के वजह से ये बढ़ता जाएगा. सो दोनों एक जगह में दोनों मैच हो जाएगा. दैट्स व्हाई द पॉइंटर स्टॉप्स एग्जैक्टली एट दैट पॉइंट ऑफ टाइम. मतलब एट द टाइम में इसका कॉइल का टॉर्क एंड रीस्टोरिंग टॉर्क दोनों मैच हो जाएगा. दैट्स व्हाई इट स्टॉप्स. ओके, तो देखो, as the coil rotates, the spring and fine wire twist and generates restoring torque. Restoring torque. Okay, and restoring torque कितना है बोलते हो, they given like this. देखो, twist and the restoring torque. Restoring torque. Okay, this manufacturer will be given based on the spring. Manufacturer will be given. Suppose मान लो 1 degree twist हुआ, 1 degree twist हुआ, तो इसका restoring torque value will be given by the manufacturer. We call it as C. We call this as C, torsional constant बोल के. They will give 1 degree twist में इतना restoring torque the spring can produce बोल के manufacturer will be given. If you tell me 2 degrees में how much restoring torque will be, 2C. अगर 5 degrees में it is 5C or C5. So this is the restoring torque acting on the coil. Okay, C value will be given on this. Okay, so क्या है restoring torque का formula is, now you got formula, restoring torque is equal to C5. So normal torque का coil का आ गया NIAB, and this is the restoring torque C5. Okay, चलो now क्या होगा. No, C is called torsional constant बोलते हैं. लिखो torsional constant. Sometimes some books में they'll give K also, no problem. C भी they are taking. Okay, so what is torsional constant means? Restoring torque developed per unit degree twist. 1 degree twist में कितना restoring torque it is acting, that is called torsional constant. restoring torque developed per unit degree twist. Okay. Now, at some point of restoring torque becomes so large that it balances the applied torque coil. It balances the applied torque coil. That means here, torque of coil is equal to torque of restoring torque. Restoring torque. Okay, torque of coil कितना है? NIAB. And restoring torque you got as C5. Right? Phi is a कितना angle में घूम रहा है ना? That is called phi. Right? Now from this I is equal to how much? I is equal to C by NAB phi. If you see, C is constant, torsional constant, and N is constant, A is constant, B is constant. In sabhi ko I call as one more constant. I will call as G. G is equal to C by NAB, and G ko we call as galvanometer constant. Galvanometer constant. Galvanometer constant. That means if I can tell like this, I is proportional to phi. This is the important thing. So आपको क्या है? It depends on only on the rotation only. How much current I pass, that much angle it should rotate. So it should be direct relation. That's why theta को भी we should not dependent. Sin theta को 90 बना दिया. That's why only I is proportional to phi आएगा. I is proportional to phi. So आपको formula remember करने का whenever moving coil galvanometer, any coil is rotating, okay, moving coil galvanometer में you have to remember this formula. That's it. NIAB is equal to C5. NIAB is equal to C5. Here C मालूम है, phi मालूम है. Phi should be in degrees only, no problem. Directly you can put degrees. C is called torsional constant. I is current, area, magnetic field, number of turns. Oh, yeah. So what is the formula we have to learn? NIAB is equal to C5 is the formula. Always equate that one, you will get the answer. But the moving coil galvanometer वही है. We have to prove that I is proportional to phi. Okay. ये मैं किस करेंगे? हाँ करो. A rectangular coil of area is given consisting of n turns suspended in magnetic field. What current should be made to pass through it in order to keep in equilibrium at 45 degrees with the field? He's telling what current I find करने का. That's it. And torsional constant value is given 10 power of minus 8. Torsional constant is C. Find current. So use the formula NIAB is equal to C5. कितना?
So we substitute phi as degrees
45
only.
only. Yes. 45. Right. So use the formula NIAB is equal to C5. So I find करो.
9 into 10 power minus 8.
Minus 6 है. I is equal to, if you
Minus
solve,
6,
you'll get I is equal to 9 into 10 to the power of minus 6 amperes. Just substituting only the formula. I have substituted also. Yes. Next one. A coil of a pivoted type of galvanometer has turns this much. Area is given, magnetic field is given, and radial magnetic field. C value is given. Find the angular deflection of the coil. मतलब phi is telling to find. angular deflection is 5. And current is given as 10 power minus 7. We give options also.
Thirty degrees.
So 30.
Yes, 30 degrees is answer. Okay. So next two topics, small topics are there. Sensitivity of galvanometer. We have two types of sensitivity: current sensitivity and voltage sensitivity. Current sensitivity is a galvanometer is a current sensitive if it produces large deflection for a small current. Small current I will pass. If it is showing large deflection, that is called as current sensitivity. That is called as current sensitivity. So current sensitivity का formula है is nothing but phi by I. Okay. Now tell me NIAB is equal to C phi. This is the formula, right? So from this, what is phi by I is nothing but NAB by C. This is called current sensitivity. This is called current sensitivity. NIAB by C. Here N is number of turns area. They'll ask theoretical questions. As the number of turns increases, what will happen to the current sensitivity? If the torsional constant decreases, what will happen to current sensitivity? I suppose inverse relation, right? Next one is voltage sensitivity. Voltage sensitivity means deflection produced per unit voltage applied across the terminals. So it is nothing but simply phi by V, which is nothing but Vs. Voltage sensitivity ko we represent as Vs. And V is nothing but IR, right? So phi by IR. And you know already phi by I. Phi by I is nothing but NAB by CR. R is called resistance. V got IR, right? And phi by I, you know, NAB by C. This is called voltage sensitivity. Okay. So here question they will ask, as the number of turns increases, what will happen to the voltage sensitivity? As the number of turns increases, what will happen to the voltage sensitivity? Anybody?
Will increase.
No, it will not increase. Why? इसमें देखो resistance है नीचे. As the number of turns increases, length increases. R equal to rho L by A, right? Resistance also increases. So no effect on this voltage sensitivity. So this one mostly will ask. And we have a relation between voltage sensitivity and current sensitivity. Vs is equal to Is by R is the formula. Is a voltage sensitivity is equal to Is by R. It is like not Ohm's law. It is not like Ohm's law. So when the current sensitivity is given, resistance is given. If you divide, you will get voltage sensitivity. Okay. Chalo. A question karo. If the current sensitivity of a moving coil galvanometer is increased by 20%, current sensitivity को 20% increase किया तो the resistance also increases by 1.5 times. What is the percentage change in voltage sensitivity? You know percentage change का formula. Change by original into 100. Change by original into 100. So original current sensitivity, initially they don't have value, right? Yes. So how much will take current sensitivity? Since we don't know the current sensitivity, he told it is increased by 20%. So 100 le lo. You can take 100. We can't use error analysis here. Why? 20% or ना always error analysis below 5% में error analysis में right आएगा आंसर, but इसमें 20% है, so that error analysis will show wrong. Okay, so IS 100 ले लो, resistance भी हाँ 100 ले लो, तो कितना होगा voltage sensitivity here? Voltage sensitivity is equal to current sensitivity by R, right? So 100 by 100 is 1. This is a voltage sensitivity, initial voltage sensitivity. Now क्या बोला? Current sensitivity is increased by 20%. So now 20% increase किया तो current sensitivity will become 120. And resistance increase by 1.5 times. मतलब इसमें 1.5 times अगर multiply करोगा कितना आएगा? 1.5 times increase किया तो कितना होगा?
15.
150 या 50 या?
150.
So 150. Now here now voltage sensitivity कितना है? New voltage sensitivity is 120 by 150. So 3 5 15, 3 5 12. That is 0.8 voltage sensitivity. Now he's asking change. Change means change by original into 100, right? So change is 1 minus 0.8 by original is 1 into 100. So it is 0.2 into 100. That is how much? To 20%. 20% change over totally. Answer is 20%. So by this your complete chapter successfully done. Okay.